Welcome to another teardown video. This time we're starting on the floor, and it's because this thing is really difficult to get up on the table, and we're having some fun. Why don't you start, Hello. Okay, let's try this. Because this thing is 27.1 kilo. What the heck? It is also very, very big. Oy, 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 oy. Look at that beast. All right. Whee! But look at that fantastic thing. It's full of all sorts of fantastic knobs, and they're connected with some mechanical pull things inside. Look at all these. You got 4 of them that is moving. See also those tiny little markers. So this is for controlling the sweep. We got all sorts of different sweep speeds, even line sync. Huh. What is all this? We can also amplitude modulate. Yeah. Marker sweep. The external. We can manually start this. All right. This is going to be interesting. But there is something that is rattling around in this unit. So I am a little bit afraid of just plugging this thing in. And it's very, very heavy, so I can't really shake it and figure out what's going on. So I really need to pull apart the top and the bottom, the covers, and let's see what is inside, and maybe we'll find the loose piece. Phew, this mega beast is now on the table, and I have loosened the screws. Oh no. Oh, this is not going to happen, is it? This thing is full of tubes. My God, this is old stuff. Oi, 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 oi. So yeah, this is a tube thingy. It's a long time ago since I pulled stuff apart full of tubes. Oh, isn't this just fantastic? This is going to be fun. So where is the little loose thing? Got a lot of trimmers, and we got a bad breath coming out of this relay. And I see a little bit of funny dust down there. This is the RF plug-in module. Really, really fancy stuff. So the idea about this unit is the main frame is a standard unit, and all you change is the readout scale depending on what RF plug-in module you have. So they can be pulled out, and I think the interface to this RF unit is exactly the same, because if you look on the internet you will find a lot of different, and they got exactly the same name, and they don't even specify the frequency. Then you need to look much deeper. What is the frequency? This is only from 0, which is actually a little bit cool if this is really true. But is this 0 to 110 megahertz? I really don't know what I can use this for. I'm just going to experiment with this and see if it works or blows up, or how many megawatts this uses in standby with all those tubes. It's going to be quite interesting to see. So I need to take off the bottom plate as well, and we will see. Look at those two ugly ones. That is really crazy. So when opening this thing in the top and in the bottom and turning and twisting the unit, I did find a little nutcase in there. So now I feel confident we're going to power this up and see what's happening. I did prepare signal cable, set up a spectrum analyzer, and yeah, the switch. I think there is something in standby and in on mode. So I would guess that I need to have this in the middle position. That will be off. This is at least what I guess, and then we'll see what happens. And at first I'll just stick in the mains cable and oh shit, fuck. Holy moly, it sounds like a jet taking off. Oy, 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 oy. Can you hear this shit? 200 watts. Oh my god. I did actually read on the back side, and it said 370 watts was the maximum. So that is why I am not so scared yet, but a little bit. Okay, so we see some. Okay, this is nice and safe. Good. So we see some bulbs for start and stop, and it's in auto standby. All right, let's plug in the output, and I put it for -40. Let's put it for -30. Holy camoly! I got output, and it's in standby. That's a little bit odd. -20. Ah, that is really cool. Look at that. -20 times 1. And what is that? That is -20. Ha ha! It's alive. Okay, so the start frequency here is what we see at the moment. So if you're looking here, alright, so if we put this for 20, ooh, if I hit exactly 20, something really bad is gonna happen. See? And if I go below here, something really bad is happening, and then it's all nice again. So there is a weirdo thingy happening. So that was actually one bug, I guess. This is 213 watts. So what is if we put it into on? Aha! So this is the sweep. So now the RF bulb is lit, and yes, it is doing sweep really fast. So this is the time for the sweep. Oh yeah. What is that one? Okay. Look at that. This thing is actually sweeping. Ha! So it seems to be working. The fun thing is when I turn this dial. Okay. There's a relay. I can hear some clickety click. Are you kidding me? Really? So this is okay. So this is the fine. Okay, that's pretty cool. But there's like a relay going clickety clack every time it starts. And really? Okay. I haven't tried anything else, but this is just start stop. I haven't. Yeah, okay. I'm gonna play a lot with this, and then we're gonna see what happens, and then I'm gonna come back and look like I'm a little bit more intelligent. So, see ya. Now I've been playing a little bit more with this thing, and I've been trying the different modes of sweeps and adjustments and whatnot, and it seems that everything is actually working that I'm playing around with. So CV is not clockwise, but it's constant wave, obviously. So when you have this mode, this is the dial that will set the output frequency, and the readout is a little bit off. See, if I put this as accurate as I can, like 10, and then I hit peaks, it's 7.6 megahertz, so it's not super accurate. But here is a funny thing. I thought this one was scale. So what scale? Is it this scale for the output power? No, scale is this. Is the frequency. Isn't that funny? So if we dial this all the way, you can see here. Let's dial this to 40 megahertz. Alright, and when I hit the switch, we get 4 megahertz. Why do you need that? What is the whole purpose of this? I don't know. I just don't get it. I don't see any difference, really, in the readout. So I don't know what that will do. 5 megahertz crystal. Maybe there's something fantastic in there. The amplitude modulation. I have the idea that I should see a dip in the sweep at the 2 marker positions. See, if we put them all like this, so we have a start and a stop and 2 markers in the middle, and then I hit auto and it is actually sweeping. I don't know if you can see the little blinks. It is really difficult to see. If I put the scope in trace max hold, you really can't see those dips. I think it has something to do with bandwidth settings. So I'll try and see if this is really true, if there is a dip. I do believe that I see 2 little, maybe something, I don't know. But look at the flatness of a sweep. I think that is pretty good when this baby here is about 60 years old. So, and it's also doing, so this is the start stop. So that means it is the start and the stop here. You can also do a marker sweep, and then it will just do a sweep between the 2 markers. So that means you can set up your test setup and do a big wide sweep and then a nice fine sweep as well. So it's actually a pretty sexy unit. Just the sound is really loud. You will remember to turn it off. And the power consumption is 235 watts. So, yes, it does work with the markers. See? Now I got 2 tiny little dips, so that means you can mark on your plotters exactly where something is, where an exact frequency is, and get this on your plot. Because normally in the good old days, those XY plotters or pen plotters or whatever you call them, they didn't really contain markers or anything accurate. It was just plotting a line. So yeah. So it's time to look a little bit deeper into this fantastic unit. Many people would call this a hybrid because it's full of transistors and tubes at the same time. They've done a lot of things a little bit interesting. look at those two power pentodes. That's actually a voltage regulator. So this is the main power supply and high voltage regulated that goes into something that is running off of 2000 volts. So I don't know if this is the main sweeper or exactly what it did, because I'm not going to dig super duper into what each tube is doing here. But look at that. You find transistors and stuff down there as well. This is just really, really nice. I'm not going to pull up any plugs today, or any boards or anything, because it was just powered up, and I don't want to get electrocuted. But this is the back side of the power supply. So it's also full of power transistors, and you can see down there some more power transistors. And at first I saw those two fuses. 25 amps? Are you kidding me? But look at that. There's actually a tiny, tiny, tiny little dot before. So it's ultra tiny dot 25 amps. That is a little bit stupid. I normally don't see HP doing anything stupid. Really? They are just so pro. And they're doing everything so well. So that's another relay. And that will be the bulb. This is one of the adjustment potentiometers down there. And I guess this is exactly C. That will be all the frequency adjustments easily located here. So you could make the scale go right. Maybe I should try and do that. This is the plug-in module. We're going to talk about the plug-in module. In the end, I think I will take this out and then we'll look at the plug-in module. But that was the top side view of this big unit. Now I'll swap it. So this is the bottom side. And I think we're still playing with the power supply. And this is the left side, it would be. But hey, look at this one. The relay here. So this is mounted on a little plate, 45 degrees, where they could just squeeze it in. That is not up to standards, isn't it? And those are really cute diodes. You would think they are transistors, but no. 2-pin diodes, all of that. Ooh, and look at that big thingy here. I still haven't thought about what is inside this big case. This is mounted directly under the main transformator. Maybe this is another transformator, but it is completely shielded. Yes, I saw some holes down there, and some cables are going into this unit. So there's gotta be something fantastic inside this case. And this is the bottom side of the main high power regulator. See all those? Those are actually 3055s. So big power NPNs. A board with only transistors and stuff. Cute. Don't you just love this board? Tiny transistors, and this is a dual transistor and then a tube. Oh, I love it. Yeah, but this is just, they knew how to deal with tubes, and they just had everything ready for that. So let's just play with tubes and transistors and stuff. in one big mix. So this is truly a hybrid. Oh, look at all that wire harness. So go figure out how to mount this, but everything is color coded. Really nice, so you can debug this and you can figure out what is going where. I don't know about open switches. You can get a lot of dirt and stuff in them, but I guess you can also clean them. Yeah, there isn't much more to see here on the bottom. Oh yes, there is one thing that is important to mention. And again you see those plug-in modules. This is just so nice when you want to service your unit. This one plugs into everything on both sides. They're using the same connectors. Really, really nice. This is something that a lot of people could learn from when they're designing stuff. Ah, it's not getting in that easy. Let's look a little bit on the back side. See, that was okay, it was 365 watts, but luckily it uses a lot less. And yeah, voltage selection, and see, pin lift and blanking. Ooh, so you can turn off the output when you're going back. That is nice. Marker and blanking. So clearly this is the kind of the documentation from the good old days. And this is the plug-in module, the outputs from the plug-in module. And there's a big nasty handle here. This is just so much avionic kind of. Oh fuck me, this is heavy. Oh, I can't even lift this up with one hand. I need two hands. Oh, can I really do this? I have to put it down. Whew, I'm getting too old for this shit. So look inside. Now we're looking inside the RF module bay. And I see two different kind of connectors. And look at those hardcore alignment, and connectors are of course mounted so they can move a little bit. Really, really smart. And look at this. This is one of the front panel knobs, and this the backside of the potmeter, of course. So this potmeter actually goes in here at the back of the module through this hole. And I would imagine all this was done way before CAD and 3D modeling and 3D CADing like you design stuff today. So can you imagine figuring out all those things just from blueprints and drawings in 2D? I am actually amazed they could do this. So all the plastic parts here, they could be reused for a lot of different models, different frequency ranges and all that stuff. And of course you could fit in another connector here to do additional features. So after playing with this unit, I left it for 3 days without power, and I've been measuring on the capacitors and the anodes and some of the points where I had an idea it could be dangerous. But I find 0 volts everywhere, so I feel we can continue looking more into the main unit. I will cover the plug-in module in another video because this video is gonna be way too big. And look how they aligned all the trimmers, so you can access everything really, really easy. I love the way that they laid out design PCBs in the good old days. Everything here is just lined up. Isn't this just lovely? Look at this PCB with all the voltage regulators. See, they use neon bulbs for high voltage center regulation. So this would probably be some voltage regulation and stuff. And a relay and a big capacitor and a shielded tube. Really, really nice. And again, lots of transistors and diodes and stuff. A true hybrid design. So here's the next. And this is where the regulated 2200 volts or something like that comes in. And this is, I think this is actually used to generate the really, really linear sweep voltages. But it's divided down to a low voltage sweep that goes into the module. So if you could generate really, really nice and linear sweeped voltages by having lower voltages, of course they would have done it. But they just knew how to work with tubes and to work with really, really high voltages. But can you imagine this board is working at 2000 volts? I really like the shielded sockets or the shielded plug in or on here on the tubes. Let me try and take one off so we can see. Okay, so this is just a standard dual and look at that, real good electrical shielding. I also think that this elastic material is to make sure the tube is not overheating or something, because this way it can still conduct heat, you know, from the glass into this piece of metal, and then it's going to work. At least this unit was still working after all those years, so this can't be too bad. But of course you need to isolate and shield the different tubes, because what you see here on the outside, that will be the anodes, and of course it's high impedance circuits, so it's going to couple to each other. They need to put them really, really close here. See that? So it's good with shielding.